We will now find the derivative of the function f of x equals 2 over x plus 8. So basically there are multiple ways to find the derivative of this given method. Here I'm going to discuss about two methods. That is, in method 1, we will be utilizing the constant multiple rule as well as the power rule. So these two rules will be utilizing the method 1, and in method 2 we'll be using the quotient rule. So let's start by differentiating this one. So first let me copy this f of x. We have f of x equals 2 over x plus 8. This is a rational function. I'm going to rewrite this rational function as something like this. I can observe that this could be written as 2 times of 1 over x plus 8. And then in the next step, I'm going to rewrite this once again as a power of x plus 8. So I can write down this as x plus 8 raised to the power of negative 1, because x plus 8 raised to the power of 1 in the denominator. When this comes to the numerator, we can write down this as x plus 8 raised to the power of negative 1. So it's basically 2 times of x plus 8 raised to the power of negative 1. Now let's apply the derivative. So first I'm going to write down this as d by dx of 2 times of x plus 8 raised to the power of negative 1. Now we can see that we can apply the constant multiple rule, because the constant here is 2, which means according to the rule, if we have to find the derivative of a function multiplied with the constant k, we can just factor out the k and then find only the derivative of the function. Same thing I'm going to do over here. So as I see, the 2 is the constant over here. I factor out the 2 out of the derivative. So and then I derivative, or I find the derivative of x plus 8 raised to the power of negative 1. Now I'm going to apply this power rule to find the derivative of x plus 8 raised to the power of minus 1. It says that if we have to find the derivative of x raised to the power of n, it says like you have to multiply with n and then multiply with x raised to the power of n minus 1. Basically, we just have to reduce the power and put the power in front. So let's do that. So to find the derivative of x plus 8 raised to the power of minus 1, I put the negative 1, which is in the power of x plus 8, in front, and then I put this x plus 8 as it is, and then I reduce the power by 1, which is minus 1 minus 1. Here we have to note down that it is not just a simple x function, it is x plus 8 terms. It's not just an x power in the form of x power n. So you have to apply the chain rule as well. So I put a dot over here, that is, I'm multiplying with the derivative of x plus 8. So this is according to the chain rule. So we have to put this over here. Now in this next step, we can simplify this. So 2 times of negative 1 is negative 2, and we have x plus 8 raised to the power of minus 1 is minus 2, and then derivative of x plus 8 is basically derivative of x and derivative of 8, which is derivative of x is 1. Derivative of 8, which is a constant, is 0. So it just gives only 1, which means if you multiply negative 2 with 1, it's not going to change the value. So we can simply write down this as minus 2 times of x plus 8 raised to the power of minus 2. And now this could be written in the positive powers of x plus 8. So the better format to write down this is minus 2 divided by x plus 8 raised to the power of minus 2. So this is the derivative of the given function f of x equal to 2 over x plus 8. We will now define the derivative of the same function f of x equal to 2 by x plus 8 by another method. So let me show that method. This is method 2. In this method, we are going to use this quotient rule. So let me copy the f of x. I have f of x equals 2 over x plus 8. And this time I'm not going to write down this as I did before in the first method. That is, I'm not going to write like this. I'm just going to keep the rational function as it is, which means this is a numerator part and this is the denominator part. Now we can apply the quotient rule. So let's review the quotient rule. If we have functions f of x over g of x, and if we have to find the derivative, the rule says you take the function g of x, that is in the denominator function, multiply with the derivative of the numerator function, that is the f prime of x, and then you put minus, then you take the f of x and then product it with the derivative of the denominator function, that is a g prime of x, all over g of x quantity square. So this is what the rule says. So we are going to apply that rule over here. So which means first I take this, maybe this denominator is our g of x, and this is our f of x. Okay, so let's apply the quotient rule. So when you do that, I have to first take the denominator part. So I take the denominator part, product it with the derivative of the numerator part or the numerator function. So in this case, we have 2 here, and then we will have a negative. And then now we have to take the numerator part or the numerator function, take that and product it with the derivative of the denominator function, which in this case is x plus 8, and then all over x plus 8 quantity square, that is the denominator part. So we have to put this like this. Now we can simplify this. We have x plus 8 times of derivative of 2. This is basically 0. So this could become 0. And then 2 times of derivative of x plus 8 is, once again, it is just 1. And we have x plus 8 quantity square in the denominator. So now we can clearly see that this becomes 0, because 0 times any product is 0. And then in the numerator, we just have only negative 2. So this could be written as minus 2 over x plus 8 quantity square. Now as you can see from here, in both methods, we arrived at the same answer. So which clearly says that we can find the derivative of any function in multiple ways. However, mostly for simple rational functions, we can use the power rule, or if it is rational functions of two different functions which have more expressions or more terms in them, then we have to use the quotient rule. Otherwise, if it is a very simple expression like this, why we can go by this method is because in the numerator we just have only one term, that is that itself is a constant. So it's better to use the method one for this problem. That's what my suggestion would be.